Thank you. Just before I get into the slides themselves, if you do want them locally or you want to follow along like that, they are available here at pgjones.dev/talks. You can go and get them there. Just a quick bit about me. Like I said, you can find me at pgjones.dev or at pgjones on GitHub or on Fosstodon. I maintain or help maintain the Palettes projects, including Flask and Quart. I'm the author of Hypercorn. I currently work at Cureleaf International. I've been a PSF fellow since 2023, which was great. So, I think I can write better SQL than ORMs can generate, and I think all of you can as well. And for this reason, I like to write the SQL. And it's not really the SQL I can fit on a slide that's going to be different, really, that's going to show this. It's more when you've got quite a few joins or you're worried about the performance of it. So I like to write the SQL, and that's what this talk's going to be about. But I do like to keep the kind of type checking and the editor hints you get from using the classes for it. So this is typically an example of how I set up my code. So I've got a function here to select the products. I write the SQL query. I execute it in a DB engine. And I turn it into the instances of this product class to use elsewhere in the code base. So this tends to start quite simply. So if an example for this is an update product function. And I'm going to use the product example throughout, just so it's familiar. But in this example, I'm going to take a product ID, a name, and a price, and I'm going to write the query to update it. And these parts here are quite important to this. These are placeholders. This is the async PG format, which I've chosen because it matches the values array, and I think makes it a bit clearer. But other dialects are very common with question marks, if you've seen it. And these placeholders are quite important for SQL injection mitigations, which I'll come to later. You can see here, I write an update function. It takes 3 values to go with it, and I can just execute this as you'd expect. It's quite easy to do. But it quickly becomes quite difficult to manage. So sometimes, perhaps in this very simple table, I want to update the price. But other times, I want to update the name. So now I have 2 functions. The first one to do the price alone, where the query is a bit simpler. And the second time to do the name alone. Again, just changing the query a little. The rest of the code is almost exactly the same. And you can see this is only for a really simple table where I'm just changing 2 columns, or sometimes one, sometimes the other. So this is a pain that kind of gets away from you. And I think this is why a lot of people reach for, and myself as well, a query builder for this. So a good example, which I've tried to show here, is SQL-alchemy. And just to note, this product here is not the data class I showed earlier, but rather an ORM type class instead. And in this example, I can make the name optional and the price optional, and I can only set it as a values part of the query, the statement, if it's not none, and the same for price, and then execute it. So it's pretty clear. I'm building the same query. It's an update query. It has a where clause and a couple of set values in it. But like I said, I prefer to write the SQL, and this, in my opinion, gets a bit out of hand when it gets a bit more complicated, and I think the SQL is clearer. So one way that this can be done, and it's getting quite close to what I like, is to use Ginger SQL. So Ginger is a templating language, and Ginger SQL builds on top of it to make sure that the placeholders are used rather than the direct values into the template itself, which is, again, quite important, but I'll show that slide later on. So in this example, it's the same function signature. I just had to scrunch it up a bit to fit on the slide. And the template uses Ginger's language to see if the name is set, and if so, it adds that to the query. And likewise, if the price is set, it does the same, and then sets the ID to the product ID. And so this is an example of rendering a template to get the query out. And it's quite close to what I'd like to do, but this templating language isn't Python, and it isn't as clear as I think it can be, which I'm going to come to in a second. So with that setup, hopefully, of the problem or what I'm trying to solve, it's now time to introduce T-strings, which is new to the language, and I'll come through that now. So I think we're all we'll know what F-strings are. And so an F-string is a string prepended with the F prefix, and what it allows is a very clear and concise syntax to build a string up, placing values directly into it. And this one I think is quite clear, but clearly the value of value, which I should have chosen a different name for, but the value of value is 2, and it puts it directly in the string, and so this is what the f-string renders to. A t-string, firstly, is just a string with a t prefix rather than an f prefix. But what it does is very different. Instead of rendering the string directly, it gives you a template that you can decide how to process or render. And the template for this simple example here consists of the string, the value is, and a space, and then the interpolation itself, which is determined at the point the template is created. So that means it has the value at the instance this is run, the name of the value, and then some other parameters, which I'm going to skip over in this talk. So a t-string is a template that you can then do something with. So it doesn't give you a string directly. And it doesn't have to, however you process it, directly give you a string. It's up to you. So to try and tie them together, and this is an example taken from PEP 750, which introduces t-strings, you can pass the t-string template into a function, let's say, called f, and reproduce what f-strings do. So if I just go back to the definition of template, it also has a way to iterate over it, and it gives you a string first, and then interpolations, and then the string after. You always get strings either side. So in this example here, if I take the parts to restore what's going on, and I iterate over the template, I can just add the string parts directly to my result, and then for the interpolations, I can just convert them to a string and add them to the parts, and finally join it all together at the end. Now, these underscores, again, I'm skipping over, but if you're familiar with f-strings, there's formatting parameters you can pass to it, and this is what these are. And the PEP, again, 750 will show you a much better example of this that I couldn't quite fit on the slides. But hopefully here you can see that I use the t-string to create a template. It then runs this code and gives me an output that's the same as an f-string. So t-strings, I think, are a generalization of f-strings. So with that in mind, probably is useful to think about why this might be useful. Now, because you've created the template, you can pass that template to some other function that can decide how to interpolate it based on the context that matters to it. So for example, I could create a t-string here and pass it to a HTML function. And that HTML function can, as it's passing the template, decide what to escape and why based on the rules of HTML to make sure it's safe. And the same obviously is true for SQL, which is the purpose of this talk I'm going to come across to. So that's what I think makes t-strings very useful. And HTML and SQL are two of the motivating examples talked about in the PEP quite a bit. I'm sure there'll be more. So I've been hinting at this quite a bit through the talk, but why is this context key? And it's to mitigate against SQL injection vulnerabilities. So I mentioned earlier that the placeholder allows you to mitigate it because you pass the query separately to the values and the database engine deals with it. If you put the values directly into the query, then you're at risk of the user placing some interesting text into the value, such as the, well, I had to change it slightly, but the famous little Bobby tables example. So probably, like all of us, you've probably seen something like this in your code base and brings back the fear. And if you did this with this value, then your query will in fact be this, and thereafter you have issues. And the problem is with this is you really want to do this because it's so clear and concise. I think there's no nicer way really to write SQL than this. And this is where t-strings are great because I can now use a t-string and write the exact same query, pass it to a SQL parsing function that's going to know when to escape the values as placeholders and how to make it safe. And that's really the advantage of this. Equally, as I said, it doesn't just have to return a string. And for this to work, it can't, because it needs to return the query, which is a string, and all the values it's pulled out to pass to the database. So in this example here, as you can see, the query comes out as you would expect with a placeholder, and the values are the actual value for the product ID. And with this, running this way, you won't have the same issue that you had before. So what we need, really, is this SQL function to take a t-string template, using the knowledge of SQL, the context, and make it safe, so to speak, so we can use this really clear, concise syntax. So this is what SQL-tString is. It uses t-strings to build SQL, and you can find it here if you want. So it's pgjones/SQL-tString. and I'm going to talk about what it can do and how it works. So first thing, no surprises, is it has this SQL function I've been hinting at, which converts templates into SQL. So to give an example of it, if we have, using the products example I said earlier and the update, if we have a name that's equal to WPT, a price of 10, a product ID of 1, and this query here, which I think is very familiar by now, but I also think is, again, just to emphasize with the T prefix, very clear, very concise for it. You get a query that has the placeholders in, and you get the values with the current values of those variables, exactly as you'd like. But this is, on its own, not too helpful. Like, I motivated this problem by query building, as opposed to just creating a simple query. So I would say that most common query building is actually removal of expressions and clauses from the SQL as and when you need them. And for that, there's a special rewriting value that SQL-tString introduces called absent. And I'll use the same example now, but if you don't specify the name, it will take the value absent. And if you don't take the price, it will take the value absent as well. Thereafter, everything is defined the same. The query looks exactly the same, but this will now build. And the way it builds, to give you an example, is that if name is absent and the price is 10 and the product ID is 1, then the SQL function will realize it needs to take out the name expression of this query. And again, that's the key part of this, because you get the template and the SQL function can figure out with the context, its knowledge of SQL, how it should work with it. And so the query you get, hopefully no surprises, only has the price set and the ID set, and the name part is completely removed. Okay? So the next thing this library introduces is two other rewriting variables called isNull and isNotNull. In the next slide, I'll show why you want those. I'll just explain what they do here. But let's say I want to find all the products that don't have a price set yet, i.e. they're null. If I set the price to isNull, then this query will be rewritten with price isNull in that expression. And the values obviously won't exist. But equally, hopefully it's clear that if I reuse this code and pass price in with a value of, say, 10, price would be a placeholder in the query, and the values would be 10. And it would work the way I expect, so you can mix and match them in. Now, the reason you want to do that is null is not comparable to null. And if you have a problematic query, which you might have seen in your code bases slightly above, it's going to give you results you don't quite expect, or at least not what you wanted. You can actually turn this off in Postgres, it turns out, but really you want to do this, so that's where the price is null comes in. Okay, so far I've talked about variables and the uses of placeholders to guard against SQL injections. You may also think, well, I want to build a query where sometimes I change the column name, sometimes I don't have a column in at all, or maybe I change the table that's joined or any of that. How are you going to protect it, or how is this going to protect against that? Now, in this case, you can't actually use a placeholder because they need to be part of the query string. Instead, it can't be passed to the database separately. So the way SQL-tString does this is it has a context that allows you to specify valid column names and valid table names, and this is how it works. This is quite similar to how ORMs do it. Obviously, you know the table structure from the ORM class itself. And now, in this example, column and name are both valid because the column is name and the table name is products. But if it wasn't, it would just raise an error and you wouldn't get, it wouldn't proceed. And you can see the query is as you'd expect. So this is most of the query building I think you'd ever want to do. But it can get a bit more complex. And if you want to put whole subqueries in, sometimes a not. I should just say for all of these, if you pass, even here, if you pass the absent value in, the column won't be present in the query afterwards. So that's how you can sometimes add a column to it and sometimes not have it at all if you wanted to do that. But the same can be said for more complex queries where you want to put raw SQL in, say this time. And my example here is a subquery that's a bit more complex here. Again, using the same example. Now, if you make this a tString and a template as well and pass the template in, then the SQL function will simply pass it as if it was all one big tString template. So it will just carry on as before. So that's how it can tell the difference between something that might be a variable, a value it has to worry about, and a template it can deal with. And hopefully it's no surprises to see that it comes out exactly as you'd expect. So if you do like the look of this, it is available now with 3.13, but with fake t-strings. So very up to you if you want to do it. Where you pass a t function, and you've got to pass it the locals, because what it effectively does is it uses these as identifier names. Now, obviously, in reality, when t-strings are released in 3.14, you can put any expression here, but this example only uses identifier names. But it works the way you expect, and you can use it that way. Okay, so I've been using this for about the past 6 months. Python 3.14, including t-strings, is coming out in about 2 weeks, on the 7th of October. They are introduced in PEP 750. You can find this library at pgjones/SQL-tString. And the other motivating example, HTML, is there's a library called tdom, which I think is written by one of the PEP authors, which you can go and look at. And I somewhat rushed that. It's just not what I was hoping for. So I imagine there might be some questions.
Thanks, Phil. And now's the time for questions.
Thanks. It's good to see a concrete example. A lot of the times I've been listening to podcasts about t-strings, it's best for library developers, and there's not really an application that I would want in the real world for it, but this is a good example of it. My question is about absent. When I was looking at your examples, I was thinking, is this because you're dealing with none, or but that's an ORM sort of way of thinking, isn't it? You're just not including it in the render template or the t-string.
Yeah, exactly. So if it was none, which probably would look a lot familiar, then you may want to set the name to none and the price to none. So that's why I couldn't use none for this and had to use a sentinel.
Thank you so much. This is really interesting to me. When I just started out as a junior last year, this was one of the problems I was working on, and I couldn't understand why this was so hard. So it's really nice to know that there is a solution on the horizon. What I was wondering about is if you've done any investigations about performance relatively. So using this versus raw SQL, etc. Are there differences?
I haven't. So most of our queries in our code base are quite simple, not too long. It definitely, obviously, takes more processing. A previous version did cache the result, so it kind of figured it out. But I need to get that working again with actual t-strings. So I don't know the exact answer for you, just that we haven't noticed it in our code base. So
right,
can't be
yeah,
too bad.
My employer is very sensitive to performance,
okay.
hence being interested. Thank you so much, though.
So a lot of these implementations suffer from parameter order. Is it safe from I notice you've got named arguments. Can I get away with murder, for example, reuse the same string further on and it'll all handle it?
Yes, I think so. I don't think I quite know the problem you have, though. But
A lot of ODBC drivers are sensitive to the argument, the parameter order, so they use numbered parameters rather than named.
Oh, right, yeah. So this will output, you'll only output the query as a string of values, always as an array, and the values order will match the placeholder order in the string. The default is actually question marks rather than the numbered version, but that's not as clear, so that's why I went for this one. And I think pretty much all DB engines support query as a string with values as a list, so it should be possible everywhere.
Thanks. Look forward to using it.
Hi, thanks for the talk. And I'm also looking forward to using t-strings. What I was interested in, how do you deal with eliminating parts of the query? Do you have an ASC that you just don't materialize, or how do you deal with that bit?
Yeah, exactly that. So it's passed into clauses, which have expressions, and every time an expression has an absent in it, it's marked as removed, and then if a clause has no expressions left, the whole clause is removed. So if you set both of these to absent, you get a query that will probably error with just updating where in, but it would do that. So.
Thanks. Yeah, this is really cool. I'm just wondering, how specific is it to just SQL, like SQL? Like, because there are other query languages that I'm thinking of, like, well, Cypher in particular, that has a similar but like quite different sets of keywords and clauses and stuff. And so, I'm wondering how specifically flavored to SQL is it compared to like other query languages that you might want to do something similar for?
So my library is just for SQL. That's the only thing it can pass. It's got a hand-built parser in at the moment, but I'm just learned about Lark the other day, so I might take a look at that. But I mean, I think the principle could apply to any.
Yeah. Is it like specific dialects of SQL and stuff you've got as well, or is it just how you identify that it's SQL or like post-SQL versus MySQL as well?
Yes. So I mostly use PostSQL, but I'm trying to make it deal with any of them. So it's mostly okay. There's probably some bugs to be found there.
Any other questions?
Just thinking back to your answer about the question mark notation, would that then mean the values could be a dict and you have named parameters? Is that what I'm thinking of? Or?
So it always returns the values as a list.
Okay.
So it would just be that the placeholder syntax is changed to question marks as opposed to $.
Right, but still then numeric indices.
Yeah, so there's a library called buildpg, which you can use to, I think it's got colon and then the name, and then you can pass it to dictionary, and it builds a query in values. So that one's similar for that, but it doesn't use T-strings, obviously.
If no any other questions, then thanks, Phil.